Is the board just a second. Is the board visible, all of you?
Yes, sir.
Right. So we will be dealing with system of particles and rotational motion. In that, the first and foremost important topic, if we deal, it is center of mass, guys. So what is center of mass? Basically, it is a certain point where the entire mass of the system can be concentrated. So suppose if I take point masses, as you can see, m1, m2, m3 are point masses. They are taken in space. So if they have been taken in space, they will have three coordinates, guys: x coordinate, y coordinate, as well as z coordinate. So if you are taking point masses, then how will you calculate the center of mass? Right, it's very simple. If you want to find out the x coordinate of center of mass, right, x coordinate of center of mass will be used by this formula: m1 x1 plus m2 x2 plus m3 x3 plus so on divided by m1 plus m2 plus m3. Y coordinate will be found out by using m1 y1 plus m2 y2 plus m3 y3 plus so on divided by m1 plus m2 plus m3. In the same manner, z coordinate can also be calculated by finding out m1 z1 plus m2 z2 plus m3 z3 plus so on divided by m1 plus m2 plus m3. Now, if you know the coordinates, can you find the position vector? Let us say, what will be position vector of the first mass? What will it be given as? It will be given as x1 I cap, y1 j cap, and z1 k cap, guys. Similarly, can you find position vector of second mass? Yes, coordinates are given: x2 I cap, y2 j cap, and you can write it as z2 k cap. In the same manner, can you find position vector of third coordinate? Yes, what is it? x3 I cap plus y3 j cap plus z3 k cap, guys. Now, when you know the position vectors, you also know the masses. So, how can you find the position vector of center of mass? I'll simply write sigma I is equal to 1 to n mi ri bar, right? Means m1 r1 bar divided by m2 r2, m1 r1 bar plus m2 r2 bar plus m3 r3 bar plus so on divided by m1 plus m2 plus m3 plus so on, guys. This is how you can calculate the center of mass, the position vector of the center of mass, guys. Right? If you know the coordinates of point masses, right, from the coordinates you can represent their position vector. When you know their position vectors, from position vectors of the individual masses, you can find position vector of center of mass also. If you know position vector of the center of mass, you can calculate velocity of center of mass by using d by dt of rcm, guys. Rate of change in position is nothing but your velocity. And how can I write it as beta? Sigma I is equal to 1 to n mi for point masses only, guys. Mi vi bar divided by sigma I is equal to 1 to n mi. This will be the velocity of center of mass. And if you know the velocity of center of mass, can you calculate the acceleration of center of mass, guys? Yes, certainly we can calculate the acceleration of center of mass. Acceleration of center of mass will be given as rate of change in velocity of center of mass. It will be directly I can write sigma I is equal to 1 to n mi ai bar divided by sigma I is equal to 1 to n mi. Now, will internal forces be responsible for providing acceleration, guys? No, internal forces will not be responsible. Who will be responsible? External forces only will be responsible. So, what is sigma here? It is summation of all external forces. What will I get? It will be net external force divided by summation of all the masses will be total mass of the system, guys. So, always remember, motion of center of mass will get affected only by the external forces. It will not get affected by internal forces. So if you know x coordinates, x coordinate of center of mass can be found out by using this formula. Y coordinates are given, then y coordinate of center of mass by using this formula. Z coordinates of the point masses are given, then Z coordinate of center of mass can be found out using this. If you know the coordinates, you can represent their position vectors as we have represented here. If you know the position vectors of the point masses, position vector of center of mass can be written as m1 r1 bar plus m2 r2 bar plus m3 r3 bar whole divided by m1 plus m2 plus m3 plus so on, guys. So if you know the position vector, you can also calculate the velocity. The velocity of center of mass will be given as simply m1 v1 plus m2 v2 plus m3 v3 whole divided by m1 plus m2 plus m3 plus so on. If you know velocity, rate of change in velocity will be acceleration. So what we can understand, acceleration of center of mass or motion of center of mass will get affected only by external forces, guys. It is not going to get affected by internal forces. Is that clear? In the same manner, continuous masses, if you have, now when I say continuous mass distribution, there are three types of continuous mass distribution, guys. How many types of continuous mass distribution you have? You have three types of continuous mass distribution. One wherein which mass is distributed in length, guys, which is your linear mass again. Other in which mass is distributed in area, or laminar object we call it as areal mass, we can say. Other in which mass is distributed in volume, right? Volume mass you can consider. These three are continuous mass distributions again. And whenever we focus on continuous mass distributions, right, what we are going to bring into picture, guys, whenever we are dealing with mass distributed in length, we will talk about linear mass density lambda, right? It is given as mass acting per unit length. For entire object is given as mass acting per unit length. However, for small elements, we'll write it as dm divided by dx or dm divided by dy. Whenever we talk about areal mass, where mass is distributed in area, we will bring into existence a quantity called as surface mass density or areal mass density. It is given as mass acting per unit area for the entire object. If I take small element beta, we will write it as dm divided by dA. In the same manner, whenever mass is distributed in volume, we will talk about volume mass density. It is given as mass per unit volume for the entire object. For small element, you can write it as dm divided by dV. Clear, all of you? Point objects are given direct formula. But if continuous masses are there is no direct formula, guys. So whenever continuous masses are given, what we should do? We should consider a small element of that particular continuous mass, find out the coordinates of the center of mass of the given element, then perform integration. So what are we going to get? How are we going to get the x coordinate of center of mass here? It will be integral x dm divided by integral dm. Y coordinate integral y dm divided by integral dm. Z coordinate integral z dm divided by integral dm. How can I write dm value here? As you all can see, if mass is distributed in length, I can write it as lambda into dx. If mass is distributed in area, I can write it as sigma into dA. If mass is distributed in volume, I can write it as rho into dV, guys. Is that clear? Now, what is x here? It is x coordinate of center of mass of that element which we are taking. Similarly, y and z are y coordinates and z coordinates of center of mass for the element. What is dm? It is mass of the element, guys. So whenever continuous mass distributions are given, right, you cannot directly use m1 x1 plus m2 x2 plus m3 x3 plus so on by m1 plus m2 plus m3. You cannot use that. What we have to do in such cases, we have to take a small element, find the location of, because if you take a small element is just like nothing but a point again. So when you know point, obviously you can find out its coordinates. There only center of mass will lie. Right. So x, y, z are center of mass, coordinates of center of mass of the element. So first find out, take the element, find out the x coordinate, y coordinate, z coordinate of center of mass, then perform integration in order to obtain the center of mass of the continuous mass distribution. Clear, all of you? Understood, everyone? And always remember, motion of center of mass will get affected only by external forces, guys. And if I assume if net external force is zero, what is going to happen here? If net external force is zero, implies directly I can write acceleration of center of mass will be zero. What do I mean by acceleration is zero? It means rate of change in velocity is zero. Yes or no? What we can tell in this situation? If velocity is zero, derivative of zero is again zero only. So I can write here that velocity of center of mass can be zero, or velocity of center of mass can also be constant value, guys. It can also be a constant value. So whenever there is no external force, if the center of mass happens to be at rest, it will continue to be at rest. If the center of mass is moving with constant velocity, it will continue to move with constant velocity. So these things you should be aware, guys, in general. Understood? So basic things you should know again, right? Uh, for regular geometrical shaped objects, right, center of mass will be lying at the geometrical center only. We'll talk about the properties also. So for semicircular wire, all are uniform objects that we are taking, guys. If you take a semicircular wire, see, wire means it has length. So where will mass be distributed? Only in its length, guys, in the circumference. Is there any mass here? No, but center of mass is present. The center of mass can lie at a point where there is no mass also. So for semicircular wire, it will lie at a distance 2r by pi. For semicircular disk, if you take an entire disk, it will be exactly at its center. For semicircular disk, right, it will be lying at a distance 4r divided by 3 pi. If you take a uniform rod, guys, where will the center of mass exactly at center? But here we have taken a non-uniform rod. For a non-uniform rod, how much is the linear mass density here? 0. How much is the linear mass density here? Maximum, you can say, let us take it as lambda. So here it is linearly changing, guys. So what we can, if linear mass density is 0 here, can I say mass is 0? Yes. Here mass is more. So if you take a uniform rod, center of mass will be at the center. But now if you take a non-uniform rod, here you see on the left side we will have less mass. On the right side we will have more mass. So did center of mass get shifted to a location where there is more mass or not, guys? Yes. Right. So what are the points that you can understand here? Center of mass can be present at a point where there is no mass. For uniform, regular geometrical shaped objects, center of mass will lie at their geometrical center, right? For non-uniform objects, center of mass will be lying in a region where there is more mass, right? Center of mass, right? It can lie inside the object or outside the object. It may be present inside the system or outside the system. Motion of center of mass will get affected only by external forces. Internal forces will not affect the motion of center of mass. And one very important property about center of mass is the sum of moment of masses about the center of mass will be zero, guys. Sum of moment of masses about center of mass will be zero. It's a very, very important case again. Right. I have already told you about the velocity and the acceleration. So what would be velocity? If you know the point masses, if you know the velocity of the point masses, then I can write velocity of the center of mass will be total momentum of the system divided by total mass of the system, right? And acceleration of center of mass can be given as net external force acting divided by total mass of the system. Clear, all of you? Right? Formulas, anyhow, you should remember because you may get direct questions based on this, guys. If point masses are given, we can directly write m1 v1 plus m2 v2 plus so on. Accelerations, if they are given, m1 a1 plus m2 a2 plus so on divided by m1 plus m2 plus m3 plus so on, guys. Clear, everyone? Motion of center of mass will get affected only because of external forces, guys. Properties also I've told you again. Center of mass of particles lies in a region where majority of mass of the system lies, as I've told you just now. Again, it may lie outside the body or on the body. Yes or no? For symmetrical uniform objects, it will lie at their geometrical center. This also we have discussed. Right? And the very basic thing is this, guys. Suppose if I have two masses, m1 and m2, let us say they are separated by a distance d. They will ask you where is the location of center of mass. From m1, if I say directly, you can write from m1, right, location of center of mass, you can write it as m2 into d divided by m1 plus m2, guys. In the same manner, if they are asking from m2 beta, then the what will it the distance be from m2? Obviously, it will be d minus xcm now. What will it be? It will be given as m1 into d divided by m1 plus m2. So as you can see, the distances of center of mass, are they inversely related with their masses or not, guys? So this is distance from m1 mass, right? This is distance from m2 mass. So distance from m1 mass is depending on m2. Distance from m2 mass is depending on m1. So the distances will be in the inverse ratio of the masses, guys, again, right? Similarly, uh, again, you can take basic things. Sum of moment of masses about the center of mass is zero. It's very, very important again, right? And one last important point is if we talk about location of center of mass, it depends on shape and nature of distribution, guys. How is the shape of the object? In the same manner, what is the distribution, whether it is a uniform distribution or a non-uniform distribution. Rest all points, 6 7 points, whatever I've told you, those are same, guys. Clear, everyone? You can find out point masses applications, so you can do, guys, directly again. It's not a big deal. I hope you can solve those. However, I'll tell you this question. Square plate is given, uniform object, right? And what is removed? 1/4 of the plate has been cut. Where is the center of mass? They're asking. Very simple logic, guys. Initially, if I take the entire plate, will center of mass lie here? Yes, this is again case of center of mass of removed portions, guys. So can I concentrate the whole mass of the large plate at center? So how can I imagine this as? We can imagine it something in this manner. From a large plate, what we are doing, guys, we are going to remove a small plate, beta. One fourth of the plate we are removing. Okay, from a large plate, what we are doing, we are removing one fourth of the plate again. So if you take a large plate, let us imagine the entire mass of the plate is m. Obviously, what will be this part, guys? Will it be m by 4 or not? Because it is one fourth of the plate. So obviously, one fourth of the mass will come out. Now you see, if I assume the center of the square to be our center of coordinate axis, guys, we'll consider it to be origin again. So for large plate, where will center of mass lie? At its geometrical center. Whereas for this, will it lie here or not, guys? Here means it will be somewhere over here. Yes or no? Now please tell me, from here to here, it is half of the diagonal or not? Half of the diagonal means it is root 2 a by 2. You will get a by root 2. Again, from here to here, it is again further half of the diagonal or not? Yes, basically, so what we can consider, if I'll take this point, or we'll take it in different color, beta. What are these coordinates? 0, comma 0. Let us say side, entire side is A. Okay. It means from here to here, what will it be? Will it be a by 2 or not? This will be a by 2 comma 0. Okay. So automatically what we can tell? This point, if I consider this point, this is also what beta? If I take this on y-axis, is 0, 0 comma a by 2. So is it exactly at center or not? Here, this will be at center exactly. Here also it is at center only, guys. So what will be coordinates? Let us say this is first mass, this second mass. First mass is a large mass. Where are its coordinates? 0, comma 0. Second mass is a small mass. So you see, what will this, see this total distance is a by 2. This will be half of the distance or not. So I'll get it as a by 4, comma, this is a by 4, comma 0. This also will be a by 4 only. So coordinates will be a by 4, comma a by 4, guys. Now, can I consider them to be point masses? Yes. So what will be x coordinate of center of mass, beta? Very simple logic. m1 into x1, because they are point masses now, plus m2 into x2 divided by m1 plus m2. Now what is m1? Let us say total mass m. x1 is 0. What is m2? It is one fourth of the plate, so m by 4. What is x coordinate of center of mass there, guys? Now very important logic. Here, what we are doing to m2, guys? Are we adding extra half, one fourth plate, or we are removing it? Because we are removing it, I'll write the mass as minus m by 4, guys. Mass can never be negative. When I am writing minus m by 4, it indicates minus means the one fourth of the plate is being removed. Where is x coordinate of it? We got it as a by 4 whole divided by what we will get? M plus minus m by 4, guys. So what will this be? You will get it as minus ma divided by 16 whole divided by 3m divided by 16 you will get, which will be minus a by, sorry, 3m divided by 4 we are going to get. Yes or no, beta? So what will x coordinate be here? I'll get it as minus a divided by 12 I'll get. In the same manner, what will happen to the y coordinate? Y coordinate also, if you consider, if I use the same formula, m1 y1 plus m2 y2 divided by m1 plus m2. You are not adding the masses here, you are removing the masses. If you take the entire square plate, it is at 0. For the small plate, mass is what? M by 4. But this mass is being removed, guys. So I'll write minus m by 4. And where is y coordinate? Again, it is a by 4 only. What are we going to get again? Divided by m plus minus m by 4. So y coordinate also you will get it as minus a divided by 12. So where is center of mass now? The new initially center of mass was lying at the center, at the geometrical center. But what is new center of mass location now? It will be at minus a by 12, comma minus a by 12. Right? So what will be distance from origin if they are asking? What is it going to be? Under root of minus a by 12 square plus a by 12 square, minus a by 12 square only, which I'll get it as 2 into a by 12 square, which I'll get it as 2 into a by root 2 into a by 12. So what we can write this as, root 2 means I can write as 6 root 2, I believe. Yes or no, all of you? This would be the distance from the origin again. Where did it shift? It is negative. Both x coordinate and y coordinate are negative. So where did it shift, beta? It shifted somewhere over here. See. For entire plate, it was at the center. From the plate, I have removed one part. So where will center of mass shift? It will shift at a region where there is more mass. Right? So what I have assumed for the entire plate, I have considered it to behave as a point mass. For this 1/4 of the plate also, I have considered it to behave as a point mass. Found out the coordinates and just applied the formulas for the point masses, guys. Clear, everyone? This is again, these are very important because previous year also similar type of question has been asked. Understood, everyone, how to find center of mass of removed portions? I hope you understood. This also you can do again, right? Not necessary, not that much necessary, guys. Again, this question is important. Let us see. It is also called as man-Planck system. So initially, Planck is at rest. Man is also rest. So what is initial momentum of the system, beta? Initial momentum of the system will be 0. This is entirely one system. This completely is one system, guys. Okay. So initially, momentum is 0. Initially, velocities are also 0. So what we can say, velocity of center of mass? It is m1 v1 bar plus m2 v2 bar. Two masses are there, no, in the system, divided by m1 plus m2. Because they are initially at rest, velocity of center of mass will be also 0. Velocity of center of mass is 0 means initial momentum of the system will be 0. Now, this is one system. Man is deciding to move to the other side, guys. Man decided to move to the other side. It means, right? So man decided to move to the other side means, is there some momentum with man? Yes. So man is moving. Is it happening inside the system, guys? Yes, it is happening inside the system. So are there any external forces? No. As net external force is 0, what will remain conserved? Momentum of the system will remain constant. What should final momentum be? Final momentum should also be 0. Initially, man is at rest, momentum of man 0. Planck is also at rest, momentum of Planck 0. Center of mass is also at rest. Is there any external force? No. Because there is no external force, will motion of center of mass get affected? No. Means center of mass should lie there itself. It should be remaining at rest only. Now what happened? Man decided to move to the right. He's walking to the right. He's walking means he's moving. He's moving means he's going to have some velocity. So when he has some velocity, then obviously it indicates that there will be some momentum to the man, guys. So momentum to the man is in forward direction. But do I need to have momentum for the entire system? No. So that is the reason what will happen. While man is moving towards right, in order to conserve the linear momentum, Planck will move to the left. Okay. So how much distance did Planck move? With respect to ground, Planck has moved x distance. With respect to ground, man has moved L minus x distance. But with respect to Planck, initially you see, man was on one side of the Planck. Now he went to the other side of the Planck. With respect to Planck, did man cover the entire length of the Planck or not? So these things you should be aware again. What is the displacement of the slab? X towards left direction, towards negative x-axis. Displacement of the man with respect to ground? L minus x. But what is displacement of man with respect to Planck, beta? Displacement of man with respect to Planck. Initially, he was on one of the end of the Planck. Now he went on to, or slab you can say, or Planck, whatever it is. Right. Now he went to the other end of the Planck. So what is displacement of the man with respect to Planck? It will be length of the Planck, guys. Initially, man is at rest. Planck is at rest. Center of mass also will be at rest. Man is deciding to move. So while man decides to move, that is happening inside the system. Due to internal forces, motion of center of mass will not get affected. So what will happen? The center of mass will continue to lie at the same point at rest, guys. So if man is deciding to move to the right, in order to conserve the linear momentum, the Planck will decide to move to the left. So with respect to ground, Planck will move x distance along negative x-axis. With respect to ground, man will move a distance of L minus x. But with respect to Planck, man will move a distance of L, guys. Clear all of you? Yes or no? So what is the displacement of Planck? M into capital L divided by M plus capital M. And what is displacement of man? Capital M into L divided by small m plus capital M. Always remember, very important case, guys. The ratio of displacement of man to the displacement in Planck, it will be in the inverse ratio of the masses, guys. Mass of the Planck divided by mass of the man. So what is minus sign going to indicate here? They will get displaced in opposite direction. However, will center of mass change? No. Location of center of mass will not change. It will continue to be at rest because there is no external force which will affect the motion of center of mass. Clear, everyone? Yes or no? I hope it is clear. Right? All these we have studied in circular motion also, guys. Right? What is angular velocity? Velocity was dr, rate of change in position. Here we are going to get angular velocity. It will be rate of change in angular position, theta bar, you can say d theta bar. Small angular displacement is only a vector quantity, guys. Large angular displacement is not a vector quantity. In the same manner, what is acceleration? It is dv bar divided by dt. Here we'll have angular acceleration. It is given as d omega bar divided by dt. Right? Now there is a relation between velocity and angular velocity. What is it? Between speed and angular speed, we know v is equal to r omega. But in velocity terms, what is it, beta? It is omega bar cross r bar. Right? Understood, all of you? And there are two types of relation. Whenever object is rotating, right, it means it is performing circular motion. Circular motion means either it can be a uniform circular motion or a non-uniform circular motion. If we consider a uniform circular motion, right, there will not be tangential acceleration. There will only be centripetal acceleration. If we consider non-uniform circular motion, both tangential as well as centripetal acceleration will be there. So the tangential acceleration, magnitude of which will be given as r into alpha, or I can write in vector form if you want to write, it is written as alpha bar cross r bar, tangential acceleration. Centripetal acceleration will be written as, if you consider, omega cross v will get, guys. So will be given as omega bar cross v bar. So these are important again. Tangential acceleration, alpha cross r, centripetal acceleration, omega bar cross r bar, right? Tangential acceleration is also given as r alpha. Velocity and angular velocity relation, v bar is omega bar cross r bar. These are the cases that you should be aware. We also have moment of inertia. We'll talk about it in some time, right? Then angular momentum also we will talk about it, guys. Torque also we will consider. So just like force is given as rate of change in linear momentum, torque will be given as rate of change in angular momentum. It is also given as I into alpha bar, guys. It is also moment of force. So I can also represent torque as r bar cross f bar. Okay. In the same manner, angular momentum will simply be quantity of rotation contained in an object. It is given as I into omega bar. You can also write angular momentum as r bar cross p bar. There are two types of angular momentum, guys. One will be spin, other will be orbital angular momentum. Orbital angular momentum will be due to the effect of translation. Spin angular momentum will be due to the effect of rotation, guys. There you have work done by force. Here you will have work done by torque. It will be given as integral tau dot d theta. There we have power as f bar dot v bar. Here you will have power as tau bar dot omega bar. Okay. There you have impulse as integral f bar dot dt. Here you are going to have impulse as integral tau bar dot dt, guys. These are very, very important cases that you should be aware. Whatever is velocity for till work energy power, right? Angular velocity will be the same. Whatever is acceleration, angular acceleration will be the same. Whatever is linear momentum, angular momentum will be the same. whatever is force, torque will be the same. These points you should be aware, and basic formulas that you should know. Angular momentum due to the effect of rotation is called as spin angular momentum. It is given by I into omega bar. This is spin angular momentum beta. It is due to the effect of rotation. And angular momentum due to the effect of translation is called as orbital angular momentum, guys. It is given as r bar cross p bar. Clear, everyone? Yes or no? And basically, again, if we take a case where there is no tangential acceleration, then I can use final angular speed. These are again equations of motion in rotation, guys. Uniform motion again. Uniform motion means object is performing rotation with constant speed, right? So alpha value should be constant, you can consider. Clear, all of you? So these are the equations which you can write. Final angular speed will be initial angular speed plus angular acceleration into time interval. Angle rotated will be initial angular speed into time interval plus half alpha t square. Final angular speed square should be initial angular speed square plus 2 into alpha into angle rotated. Always remember omega should be written in radian per second, guys. And angle rotated can also be given as omega plus omega naught by 2 into t. You can write it from this concept again. Just like we have translational kinetic energy as half mv square, in the same manner we are going to have rotational kinetic energy called as half I omega square, guys. What is rotational kinetic energy here? We are going to have rotational kinetic energy as half I omega square, where I is the moment of inertia. So let us see how to calculate the moment of inertia, guys. Clear, everyone? Whatever is velocity, here you will have angular velocity. Whatever is acceleration, here you will have angular acceleration, right? Whatever is mass, here you will have moment of inertia, right? In the same manner, whatever what we can consider, whatever is linear momentum there, here it is angular momentum. Whatever is force there, here it is torque. Whatever is kinetic energy, here also it is kinetic energy, but there it is translational kinetic energy. Here you will write rotational kinetic energy. There work done by force integral f bar dot dr bar. Here work done by torque integral tau bar dot d theta bar. Power f bar dot v bar. Here tau bar dot omega bar. Right. So angular impulse here, rate of change in angular momentum. Angular impulse can be written as change in angular momentum. Just like linear impulse is change in linear momentum. Integral f bar dot dt. Here angular impulse can be written as integral tau bar dot dt. Clear, everyone? Yes or no? What is inertia, Vetna? Whenever object is free to translate, resistance offered, again it is the property or resistance offered when object to change its state of rest or motion or direction of motion. That is resistance offered during translation. Moment of inertia happens to be resistance offered during rotation, guys. Where during rotation again. It is the resistance offered. Inertia, what is inertia again? It is क्या हुआ इसको? What is inertia? It is property of an object to resist any change in its state of translation. Moment of inertia, it is also property of an object to resist any change in its state of rotation, guys. Inertia, translation. Moment of inertia, rotation again. Now, if you have point masses, then I can directly write moment of inertia as sigma mi ri square. Means if some system of particles are given, point masses are given, m1 into r1 square plus m2 into r2 square plus m3 into r3 square plus so on, you can write, guys. This will be the moment of inertia for system of particle. For point masses, different point masses are given. What are r1 here? R1, R2 and R3. These are perpendicular distance of the masses from the axis of rotation, guys. In the same manner, if you have rigid body, means continuous mass distribution, can you directly write formula, guys? No. For continuous mass distribution, you should always, what we should do? We should consider an element which is going to be just like a point again, find the moment of inertia for that point and perform integration. So what will I do, guys? In case of continuous mass distribution, I'll write integral di, which I can consider it as dm into r square or dm into x square, guys. Clear, everyone? Yes or no? This is for which system again? This is for your rigid body. For rigid body, you will just perform, you'll find out, you will take a small element, you'll find the moment of inertia for that particular element, and then you will perform or do integration part size. Clear, everyone? Now, based on, uh, in order to calculate moment of inertia for different objects, we have parallel axis theorem as well as perpendicular axis theorem, guys. Please remember, moment of inertia for point masses is mass of that point into square of the perpendicular distance from the axis of rotation. Whereas for rigid body, what will you do? You will take small element, find moment of inertia for that small element and perform overall integration, guys. In order to find out moment of inertia for different objects, what we are going to do, we are going to make use of two theorems called as parallel axis theorem as well as perpendicular axis theorem. What they are saying in parallel axis theorem, let us take, we have two parallel axes, both should lie in same plane, and one among them should be passing through the center of mass. Then in that case, let us say moment of inertia about this axis ICM, this is I. Then moment of inertia about the given axis can be given as sum of moment of inertia about an axis passing through center of mass plus product of mass and square of the distance between them, guys. This is how we write parallel axis theorem. When can we apply parallel axis theorem? You can apply for two-dimensional object, three-dimensional object, for any object, guys. So in order to apply parallel axis theorem, we need to have two axes lying in same plane, and one of them should be passing through the center of mass. Then moment of inertia about the other axis will be sum of moment of inertia about a parallel axis passing through center of mass as well as product of mass and square of the distance between the two axes. Whereas perpendicular axis theorem, it is applicable only in two-dimensional space. Parallel axis theorem can be applicable for any object, guys, right? Whether you take two-dimensional, three-dimensional, four-dimension. But when we consider perpendicular axis theorem, it is applicable only for planar object. So suppose if I say an object is lying in xy plane, so which axis will be perpendicular to xy plane? Z axis. So what is perpendicular axis theorem stating? Moment of inertia about an axis passing through a given point and perpendicular to the plane of the object will be equal to sum of moment of inertias about two axes passing through the same point lying in the plane of the object and perpendicular to each other. So what is the condition here? X and y are anyhow perpendicular, but they should also be perpendicular to z axis, guys. The moment of inertia about an axis passing through the center or passing through a given point and perpendicular to the plane of the object will be sum of moment of inertias about two perpendicular axes passing through the same point, and they should be perpendicular to each other, guys. So based on perpendicular axis theorem and parallel axis theorem, we have moment of inertia for different objects, which I'm not saying here, guys, because you may already be aware. For a ring, for a disc, for a hollow cylinder, for a solid cylinder, for a rod, about the center, about one of the end, is all cases you may be aware. So that is the reason I'm not discussing them. It's better you remember all these cases, guys. Clear, everyone? Yes or no? For solid sphere, 2 by 5. For hollow sphere, 2 by 3. For rod, you please remember about an axis passing through center perpendicular to length is ml square by 12. About one of the end, ml square by 3. If the rod is inclined, ml square by 3 sine square theta. Moment of inertia about an axis passing through center and along the length, guys. One we took perpendicular to the length, it is ml square by 12. Perpendicular to the length and passing through one of the end, ml square by 3. Passing through one of the end, at inclined to the end, ml square by 3 sine square theta. But if it is passing through center and along the length, the moment of inertia will be 0, guys. Always remember, whatever is moment of inertia for a ring, same will be moment of inertia for a hollow cylinder. Whatever is the moment of inertia for a disc, same will be moment of inertia for a solid cylinder, guys. And moment of inertia, always remember, about any axis you may take, guys. Moment of inertia about any axis It can be represented in terms of mass of the object into there is some quantity called as radius of gyration. We can represent it in terms of radius of gyration, guys. So what will this radius of gyration be? It will be root over I divided by m. So always remember we should be aware of some values again, right? Which should we should be aware of k square by r square values, guys. Right? K square by r square you should be aware for a ring, right? For a disk, for a hollow sphere, and for a solid sphere, guys. So if axis is not mentioned, always consider an axis passing through the center to be the given axis. So for ring, k square by r square value will be 1. For disk, it is 1 by 2. For hollow sphere, 2 by 3. For solid sphere, it is 2 by 5. So lesser k square by r square value is there for which object, beta? It is there for solid sphere. For ring and hollow cylinder, same. For disk and solid cylinder, same, guys. So lesser k square by r square value is there for solid sphere. How much it is? 0.4, guys. Clear, everyone? Yes or no? We have some cases again of how to calculate the tangential acceleration, how to calculate the torque when force is given. As I said, torque is given as r bar cross f bar. I think you all know how to perform cross product. And angular momentum due to translation will be given as r bar cross p bar. So both the cases you have to perform cross product, guys. Questions will come again. We will be solving the questions. However, till your what do we say? Till system of particles, I'll share the brief notes after the class. Just before the end of the class, please do remind me, guys. So we have rolling motion, but before we move on to rolling motion, let us consider angular momentum, guys. Now we have something called as angular momentum. Now angular momentum is basically quantity of rotation present with the object. Just like linear momentum is quantity of translation, angular momentum is quantity of rotation present, guys. Now angular momentum can be only due to rotation, which is called as spin angular momentum, and there can be angular momentum due to translation, which is called as orbital angular momentum. Spin angular momentum is given as I omega bar. Orbital angular momentum will be given as r bar cross p bar, guys. So this condition will come in rolling cases where object performs both translation as well as rotation, guys. Right? So the angular momentum will be given as I omega bar plus r bar cross p bar. Now when I talk about for spin angular momentum, directly it is formula only, guys. But however, when we focus on orbital angular momentum, it is anyhow given as r bar cross p bar. I can also write it as r into p into sine theta into n cap. N cap is a unit vector perpendicular to both r bar and p bar, or it is a unit vector which gives direction of orbital angular momentum. So I can write it as r into p sine theta n cap, or I can write it as r sine theta into p n cap, guys. So usually when we resolve a vector, we write it as p cos theta, p sine theta. So P cos theta is parallel component, guys. P sin theta will be perpendicular component. So always remember the orbital angular momentum will either be due to perpendicular component of linear momentum or perpendicular component of position vector. In the same manner, what is torque given, guys? If we consider torque again, how is torque given? Torque is basically given as it is due to force, the torque will be present. If force only is not there, then torque will never be there. Torque is basically turning effect produced by a force. Suppose force only is not there, will there be any turning effect? No. But if forces are there, there may be torque, there may not be torque, guys. So basically torque is given as due to force, it is given as r bar cross f bar, guys. So as you all know, it can be written as r into f into sine theta into n cap. Again, I'll use this as two things. I'll write it as r into f sine theta n cap, or I'll write it as r sine theta into f n cap, guys. So the torque will be due to perpendicular component of force or perpendicular component of position vector, guys, or perpendicular component of what? position vector. Clear everyone? Right, this is how to calculate and all they have given. So we will be doing it with the help of numericals again. Then we have conservation, just like we have conservation of linear momentum, in the same manner we have conservation of angular momentum. What is conservation of angular momentum stating? What is conservation of linear momentum? If there is no force, no external force, if net external force is zero, linear momentum will remain conserved. In the same manner, if you have a isolated system, means there is no external force acting on the system, and angular momentum of the system will remain conserved. Always remember, torque will be given as rate of change in angular momentum. So if torque only is not there, then what will happen to angular momentum? Either it can be zero or it will remain constant. Some applications of conservation of angular momentum are there, which also you can try doing, guys. The same manner, one very important thing that we have, which is our rolling motion, guys. Now, when we talk about rolling motion, see, if you take this object, guys, let us say it is just moving in this manner. This kind of motion is called as translation. If you observe the fan, right, what is happening to the fan? In its position only, it is rotating. That motion is called as rotation motion. So if I say in its position only, it is performing a motion like this. This is rotation. What is rolling? While rotating, it is getting displaced. This motion will be called as rolling motion, guys. And usually in NEET, you are going to talk about only pure rolling. You will not have rolling with slipping, guys. Right? So suppose if, let us say, if the object is translating, let us say this object is translating, then every point on that object will translate with the same velocity. If object is rotating beta, because of the effect of rotation, there will be speed, guys. How will you find speed at any point? That is the effect of rotation. Along the sense of rotation is clockwise here, guys. So along the sense of rotation, at the given points, you are just going to keep on drawing the tangents, guys. Same goes with acceleration also. If this is accelerating, every point on it will accelerate with same acceleration. If it is rotating with some angular acceleration alpha, how will you find the acceleration components because of rotation? Along the sense of alpha, at the given point, you are just going to keep on drawing tangents, guys. So this will be the combined translation as well as rotation effect at every point, guys. Now this point is very important. The bottommost point is very important, guys. Okay. Now this bottommost point usually will be connected with a fixed surface. The fixed surface has how much velocity? Fixed means it cannot move. The fixed surface will have zero velocity because the lowest point will be in contact with the surface. The lowest point should also have zero velocity. So here in general, you see what is the velocity of the lowest point for the given cases, guys. Due to translation effect, I will get VCM in this manner. Due to rotation effect, I am going to get R omega in this direction. I don't know whether VCM is greater or R is greater. So what I'll write, I'll say that if I take the effect of both of these, I'll get VCM difference R omega. If it is performing pure rolling, for pure rolling, always remember, guys, for pure rolling, the velocity of the bottommost point, it should be equal to the velocity of the surface. And usually we'll consider the surfaces to be fixed only. Then I'll get VCM difference R omega will be 0. From here we will get V value to be equal to R omega. But it is not necessary that for pure rolling V should always be equal to R omega, guys. No. What is the condition for pure rolling? Whatever is the velocity of the point of the or the lowest point, that point should have velocity of the surface. Because we take fixed surface, its velocity is 0, we take v is equal to r omega. But what in reality is correct? In pure rolling, velocity of the point of contact should be equal to velocity of surface on which the object is performing rolling motion, guys. Clear, everyone? Now, suppose if v value is greater than r omega, if v value is greater than r omega means this particular point will have velocity in forward direction. So that case will be called as forward slipping, where effect of translation will be more than effect of rotation. Whereas if r omega is greater, if r omega is greater, this point will slip in backward direction, guys. That situation is called as backward slipping, right? Here, effect of rotation is more than effect of translation. If both are equal, effect of translation and effect of rotation, if both are equal, then I will say object is going to perform pure rolling, guys. Whenever rolling in slipping is there, rolling with slipping, friction will be kinetic. However, pure rolling, if we are considering, friction will be static. It may be present, may not be present, depending on the conditions, guys. Understood, all of you? Yes or no? You understand? Right. So when we substitute v is equal to r omega, we can find out the resulting velocity of every point, guys. Now, energy in rolling, pure rolling is very, very important, guys, because many questions have been asked based on this only. Now, when I say total energy in rolling, it will be equal to, because in rolling both translation is there and rotation is there, it will be equal to translational kinetic energy as well as rotational kinetic energy. If I want to write total energy in terms of only translational kinetic energy, it will be written as translational kinetic energy into 1 plus k square by r square. Right? Only in terms of rotational kinetic energy, it will be written as rotational kinetic energy into 1 plus r square by k square. Here, what is ET value, beta? It will be half m VCM square you can write, or V square you can write. And what is ER? It is rotational kinetic energy, which is half I omega square. Total energy in rolling, definite question, guys. Two times it has been asked. Question has been asked from this. They will ask you what fraction of the total energy is translation, what fraction of the total energy is rotational, right? What will be the ratio of translation to rotational kinetic energy, right? Such type of questions will definitely be asked in case of pure rolling conditions, guys. And we have two cases. We have pure rolling on a uh, horizontal surface, and we have pure rolling on a inclined surface. So let us imagine if object is performing pure rolling on a horizontal surface on application of some external force F. How is the force applied? At a distance h from the center, beta. Then in such case we can prove again, right? Let us not focus on that again, guys. The acceleration of center of mass will be given as the applied force into 1 plus h by r divided by m into 1 plus k square by r square. And friction value, if you consider, right, I'll write friction value as, it will be given as f into, you can consider, h by r minus k square by r square whole divided by 1 plus k square by r square. Clear, all of you? H by r minus, this is important. And in case of pure rolling, which friction will act? Rolling friction, you can say, or static friction basically. So it should be less than or equal to maximum value of static friction, beta, which is nothing but, here in this case it will be mu into m into g. These two formulas are very important again. Now, it is not necessary that if only applied force is there, object will perform pure rolling. If applied force is not there also, then object can perform pure rolling, and friction will be helping in that case, guys. So here if I say force is applied, then what will be the acceleration of the object? F by m into 1 plus h by r divided by 1 plus k square by r square. Friction acting will be h by r minus f into h by r minus k square by r square divided by 1 plus k square by r square. Now three conditions will be there here. What are those? If h by r is greater than k square by r square, what will happen? Friction will be, it will be slipping in forward direction, guys. So if h by r is greater, what we can consider? If h bar is greater than k square by r square, I'll get friction value positive. What is the meaning of friction value positive? it acts in forward direction. In the same manner, if h by r is less than k square by r square, I'll get friction value as negative. What is the meaning of friction negative? It means friction will be acting in backward direction. However, if h by r value is equal to k square by r square, guys, is there a necessity of friction? No. So if force applied is there, if there is some force applied for an object to perform pure rolling on a horizontal surface, depending on the force applied, friction may be present, may not be present. So is it necessary for friction to be present in order for object to perform pure rolling on horizontal surface? No, guys. If force applied is there, not necessary. But if force applied is not there, if there is no force applied, then definitely friction should be there in order to provide both translation as well as rotation. But if force applied is there necessity of friction? No, may be present, may not be present depending on these conditions, guys. However, if there is no applied force, then in that case, definitely friction should be there. And always remember, work done by friction in pure rolling. I have told you this yesterday also, guys. Work done by friction in pure rolling is how much? It will be zero. Work done by friction in pure rolling will be zero. Understood, all of you? Yes or no? And depending on where the force is applied, if it is acting at the center, at the surface, values are going to change. So let us not bother about that. The next case is friction rolling on a inclined surface, guys. So if we want to find out uh, the situation or the case for rolling on an inclined surface, all these are not necessary again. Now they will ask, so you need to know some five formulas, guys. Again, what are those? Again, there's a lot of physics behind this. What are the forces that will act? One will be normal reaction, other will be a component of one weight will be acting, friction will act. Always remember, for object to perform pure rolling on horizontal surface, should horizontal surface be rough? Maybe, may not be, depending on the force applied. If force applied is not there, then definitely it has to be rough. But for an object to perform pure rolling on an inclined surface, definitely that inclined surface has to be rough, guys. If it is a smooth inclined plane, the object can never perform pure rolling. It will not pure rolling also you take. For object to perform rolling on an inclined plane, definitely that inclined plane has to be rough, guys. Understood? So you'll have some cases again whenever object is dropped from a certain from the top of the incline. What is the acceleration? They will say acceleration of center of mass will be. Or I'll just write it. They have given. So you can write acceleration of center of mass can be given as g sine theta divided by 1 plus k square by r square. Because we are talking about pure rolling, alpha value can be given as ACM divided by r beta, which can be taken as g sine theta divided by r into 1 plus k square by r square. Then they will also ask you if it is dropped here, with what speed it is going to reach the bottom of the incline. So I can write it as VCM value will be root over 2gh whole divided by 1 plus k square by r square. Similarly, omega value can be written as VCM divided by r, which I can write it as 1 by r into root over 2gh divided by 1 plus k square divided by r square. They'll also ask you to find out what is the friction acting, guys. It will be mg tan theta. Here in friction, you will get 1 plus r square by k square. And friction, which type of friction is acting? Rolling or static friction we can consider here, guys. It should be static friction always adjusts itself. So here it should be less than or equal to mu mg cos theta. So what is mu value you will get? It will be greater than or equal to tan theta divided by 1 plus r square divided by a square, guys. Okay. And they will also ask you to find out, sorry, this will be mg sin theta beta, not mg tan theta. Friction value will be mg sin theta divided by 1 plus r square by k square. So what is the minimum value of coefficient of friction, they will ask you. The minimum value of coefficient of friction should be equal to tan theta divided by 1 plus r square by k square. They'll also ask you to find what is the angle of inclination for which object placed on it will perform rolling. So what will it be? You can write it as tan inverse of mu into 1 plus r square divided by k square. From this, you can also find out the maximum angle of inclination for which object placed on it performs pure rolling. The maximum angle of inclination will be tan inverse of mu into 1 plus r square divided by k square. And they also ask you to find the time taken to reach the bottom, guys. Time taken to reach the bottom will be 1 by sine theta root over 2h by g. In numerator, you can write 1 plus k square divided by r square. These basic formulas you should know in case of rolling on an inclined plane. For object to perform rolling on an inclined plane, definitely that inclined plane has to be rough. Rolling cannot be performed on a smooth inclined plane. But for object to perform rolling on a horizontal surface, it may be smooth, it may be rough depending on the applied force. If there is no applied force, then definitely it has to be rough surface, guys. Clear all of you? Yes or no? Right, so these are the cases that you should remember in your acceleration of center of mass, angular acceleration, speed with which you'll reach bottom, angular speed, friction acting, coefficient of friction, right? Similarly, angle of inclination and time taken to reach the bottom, guys. These values you should be aware in case of, apart from two formulas that you need to remember in rolling on a horizontal surface, these formulas you need to remember in rolling on an inclined surface, guys. Clear, everyone? So always remember, whichever has lesser value of k square by r square will reach the bottom of the incline quickly. Again, whichever has lesser k square by r square will reach the bottom with more speed. Speed will be independent of mass. Time taken to reach will also be independent of mass. Acceleration will also be independent of mass. Clear? So these terms will be independent of masses, guys. Understood, all of you? Yes or no? Is that clear? These are few things related to your uh, rotational motion again. So let us do some questions again related to rotational motion, guys. Any doubts in this? Basic formulas you remember? Let us try to solve questions so that we can learn the procedure of solving the questions, guys. Clear, all of you? Is the board visible? Is the board visible, everyone? Am I audible? Hello.
Yes, sir.
Let us solve some questions in today's class. The rest we will do in tomorrow's class, guys. A rod of length L and mass M is bent to form a circular ring. Okay. So whatever length is there, it is bent to form a ring, guys. So will length get converted to circumference or not? So what will our radius be here? You can write it as L divided by 2 pi. Okay, radius will be L divided by 2 pi. Now what they are saying, moment of inertia of the ring about its diameter they are asking. Moment of inertia of the ring about the diameter they are asking, guys. So if I consider this is your ring, if I imagine this is the ring, guys. So what is the moment of inertia about an axis passing through the center and perpendicular to the plane? Please do remember, for ring, this will be mr square, right? What is moment of inertia about a tangent perpendicular to the plane, guys? If you apply parallel axis theorem, you will get it as 2mr square. What is moment of inertia about any diameter if I take? About any diameter, you will get moment of inertia for a ring as mr square by 2. And if you take tangent in the plane, guys, right? tangent in the plane, this you will get it as 3 by 2 mr square. These things you should be aware in case of ring again. So whenever we are talking about ring, moment of inertia for a ring about an axis passing through center and perpendicular to the plane will be mr square. Tangent perpendicular to the plane 2mr square. About any diameter mr square by 2. Tangent lying in the plane 3 by 2 mr square. So now they're asking what is moment of inertia for the ring about its diameter. So what will moment of inertia be better? Definitely moment of inertia questions are very very important, guys. Mass will remain same. It is mr square by 2 as you all know. What I can write m by 2. What will radius become beta? L by 2 pi whole square. So the moment of inertia will be ml square divided by 8 pi square. Clear everyone? Understood all of you? Yes or no? When no external force is acting on the particle, the center of mass of the system, what will happen? If it is at rest, it will continue to be at rest, right? If it is moving with constant velocity, it will continue to move with constant velocity. So third option will be correct, guys. Now they have given us two homogeneous disks of mass m and 3m, which have radius 3a and a, are respectively are placed in touch. The distance of center of mass from disk A, they are saying, guys. So two disks have been given to us here. This is one of the disk whose mass is m, radius is 3a, right? And you also have one more disk whose mass is 3m and radius is a only, guys. So I have here we have two disks like this. So one of the disk is A, the other disk is B. This has mass 3m, this has mass m. Okay, now I'll assume because they are in contact with each other, we will take it something like this. Homogeneous means uniform, guys. For uniform regular geometrical shaped objects, where will center of mass lie? At their geometrical center. Here also somewhere over here. From here to here, what is the distance? Radius, which is 3a. Here, what is the distance? A. So if I assume this to be 0, comma 0, automatically this will become what beta? 4a, comma 0. They're asking distance of center of mass from the center of disk A, guys. So what we can write here, I can use now because they're point masses. So I can use xcm of x coordinate of center of mass will be m1 x1 plus m2 x2 divided by m1 plus m2. First mass is m, x coordinate of center of mass 0. Second mass is 3m, x coordinate of center of mass lying at a distance 4a divided by total mass is m plus 3m, guys, which I'll get it as 12ma divided by 4m. The answer should be 3a. Clear everyone? Understood all of you? Is that clear?
Yes, sir.
A uniform circular disc has radius 20 centimeters. A circular disc of radius 10 centimeters is cut concentrically from original disc. Shift in center of mass they're asking. Disc is given, guys. What is given? Disc is given. From this disc, what is happening? We have done similar type of question just now. Another disc is removed. Okay, something like this. So initially, the large disc had how much? So what will be left here, guys? We will be left out with this portion. This is also called as annulus of a disc, guys. It is also called as annulus of a disc. So what has happened in this situation? From a disc of radius 20 centimeters, let us say it is 2r. Okay, a smaller disc of radius r has been removed, guys. They're asking what is the shift in center of mass. Originally, for the large disc, where will center of mass lie? At the geometrical center. Now I need to find where will be the location of center of mass, guys. So very basic logic again, because they have been cut out concentrically, center of mass will still lie at the center only, which you can consider it as 0. Clear? Or how will you solve for this question, beta? Let us imagine this is mass m. This has mass m dash. Whole mass m will be distributed in pi into 2r whole square area. M dash mass will be distributed in pi into r square area. So can we perform crisscross or not? Yes, we can perform crisscross. So what will I get? M into pi r square will be equal to m dash into 4 pi r square. So what will m dash value be, beta? It will be m divided by 4. Now, what will you, again, I can, if you take a larger disk, I can consider the whole mass to be at the center. If you take the smaller disk also, I can take the whole mass to be at the center. So where is center of mass lying? For first disk also it is lying at 0 comma 0. For second disk also it is lying at 0 comma 0, because they are point masses. Even if I use the formula m1x1 plus m2x2 divided by m1 plus m2, what will I get, beta? 0 plus how much mass is removed now? Because this mass is being removed, I'll write minus m by 4. Where is it lying? Again 0 only, divided by m plus minus m by 4. Because they are cut concentrically, guys, there will not be any shift in the location of center of mass. But they will give you, it is cut something in this manner, let us say. It is cut like this. Then there will be shift in center of mass. Understood, all of you? Right? Some cases like this may be given. This is very important, which you can solve it, guys. Did you understand, everyone? Is that clear? Definitely such type of questions will be asked. There will not be any shift in the center of mass in this case. Next, radius of gyration for a uniform disk about an tangential axis lying in the plane of the disk. Now, if I consider a disk, guys, mass in case of a disk will be distributed in its entire area. You have different axes. Moment of inertia for a disk about an axis passing through center and perpendicular to the plane, mr square by 2. About a tangent perpendicular to the plane, 3 by 2 mr square. These all things you should remember, guys. About any diameter you may take, guys. About any diameter, it is mr square divided by 4. And about a tangent in its plane, beta, you will get it as 5 by 4 mr square. So what are they asking? They're asking us to find radius of gyration for a disk about a tangential axis lying in the plane. So this axis they are asking. So what is moment of inertia about a tangential axis? 5 by 4 mr square. Right? And I said just now, moment of inertia about any axis can be represented as mass times of radius of gyration whole square, beta, which is 5 by 4 mr square. From this, what we can cancel out? M and M will get cancelled out. K square value will be 5 by 4 r square. I will get K value as root 5 divided by 2 into r. Clear, everyone? Understood or not? Yes or no? Right. Next question, let us see. They have given us two vectors, a bar and b bar. Unit vector perpendicular to a bar and b bar they are asking. Always remember, let us say n cap is that unit vector perpendicular to a bar and b bar. Unit vector perpendicular to a bar and b bar will be given as a bar cross b bar divided by magnitude of a cross b, guys. Now, how will you perform the cross product is very important. As you can see, both the vectors have three components, guys. So vectors are in space. Then what will we do? First, in first row, I will write unit vectors in space, guys. I, J, K. What is first vector here? A bar. In the next row, I'm going to write the components. You see here, component will be 1, 1, 2. Then in the third row, I'm going to write the components of second vector, 2, minus 2, and 1. So I am trying to calculate what beta I am interested in finding a bar cross b bar. Easiest method will be determinant method, guys. So what I'll do in order to find x component, I will block the column and the row in which I cap is present. What are the elements left out? 1 minus of this. So if you solve for this, what will I get, beta? I'm going to get 1 into 1 is 1, minus of minus 4 will be 4. So I'll get it as 5. Coefficient of this will be plus, guys. This is minus, this is also plus. So what are we going to get? Plus 5, or 5 plus I cap you can write, plus. Now I want to find y component, guys. In order to find y component, what we are going to do? You are going to block the column and the row in which j cap is present. So what are the elements left out now? 1 into 1 is 1. 2 into 2 is 4. 1 minus 4 will be minus 3 you will get, guys. And coefficient of j cap is minus, guys, again. Plus. I want to find z component. In order to find z component, what we are going to do? Again, we are going to block the column and the row in which z k cap is present, guys. So what are the elements that will be left out with? 1 into minus 2 is minus 2. Minus 2 again you will get, which will be minus 4. And coefficient of k cap will be plus k cap, guys. So I'll get it as 5 I cap plus 3 j cap plus 4 k cap. This will be the A cross B. Just give me a second. Am I audible and visible, guys? So this is
Yes,
how
sir.
we perform cross product of vectors again, right? If vectors are represented in space, means they are going to have three perpendicular components, guys. So I'm going to perform cross product in such manner. If I want to find x component, I'll block the column and the row in which I cap is present. Whatever elements are left out, I'll do crisscross. So 1 minus of minus 4, 5 you will get. And when I want to find y component, I'll block the column and the row in which j cap is present. So elements left out will be 1 and minus 4. You will get minus 3. If I want to find z component, I'll block the column and the row in which k cap is present. Elements left out will be these, guys. So minus 2, you'll get minus 4. Now what will be magnitude of this? Magnitude of A cross B if you take. What will I get, beta? You'll get it as under root of 5 square plus 3 square plus 4 square, which turns out to be 25 plus 25, which is 50. You will get it as 5 root 2, beta. So what is n cap now? You will get it as 5 I cap plus 3 j cap plus 4 k cap divided by 5 root 2, which will be 1 by root 2 I cap, 3 by 5 root 2 j cap. So this is minus, okay. Minus 4 by 5 root 2 k cap. So please understand what is a unit vector perpendicular to both vectors. What is it given as? A bar cross B bar divided by magnitude of A cross B. So understood how to perform cross product? If you know how to perform cross product, you can calculate orbital angular momentum R bar cross P bar. You can also calculate torque R bar cross F bar, guys. Understood, everyone? So here the answer should be third option. Clear? They're asking what is magnitude of A cross B square plus A dot B square. What is A cross B magnitude? You know it is AB sine theta whole square. What is magnitude of A dot B? It is AB cos theta whole square. So what are we going to get, beta? You will get it as A square B square sine square theta plus A square B square cos square theta. So if I take A square B square common, you will get sine square theta plus cos square theta, which is anyhow 1. So our answer should be a square v square, guys. Cross product we usually study in your system of particles, guys. Till dot product we study in work energy power. Cross product we usually study in system of particles. So a bar cross b bar will be given as a into b into sine theta n cap. So magnitude is ab sine theta. Direction will be given by n cap, guys. Right. Let us see the next question. Two balls are thrown simultaneously in air. The acceleration of center of mass of the two balls while in air. Right. Two balls have been thrown, guys. Right. Now they have not given anything related to masses. So whenever you are throwing any object in air, will it be moving under the effect of gravity? Yes. So if you take first mass, it will move under the effect of gravity. G will act always vertically downwards. A2 will also act G minus J cap always vertically downwards. So what will acceleration of center of mass be, beta? It will be, as you know, m1 a1 particle. Two balls have been given, guys. Again, if you consider them as point masses, I can write m2 a2 bar divided by m1 plus m2. So obviously, masses are not mentioned here, right? They have not said that they are identical balls. At least, if they have said identical balls, you would have got the acceleration. But because nothing has been specified here, so I can write m1 into g minus j cap plus m2 into g minus j cap divided by what will I get, beta? M1 plus m2. So if I take g common here, what are we going to get? You will get m1 plus m2 minus j cap divided by m1 plus m2. So what will this be? It will be g minus j cap. If both have same acceleration, guys, then it will be equal to g. It will not be depending on the masses. Understood, everyone? Clear, all of you? In this question, they are asking us to find out the instantaneous angular position is given, magnitude of angular velocity of the point when angular acceleration becomes zero. So if angular position is given, what is angular velocity? Rate of change in angular position, which I can write it as d by dt of 2t cube minus 6t square. So directly I'm doing differentiation here, guys. You will get it as 6t square minus 12t. Now you know angular velocity. How will you find angular acceleration? It is d omega divided by dt. So I can write it as d by dt of 6t square minus 12t. If I do differentiation, I'll get it as 12t minus 12. Now if alpha is 0, when will alpha be 0? 12t minus 12 should be equal to 0. 12t value will be equal to 12. The t value will be 1 second. So alpha will be 0 at 1 second. In that case, what is omega value? Omega at t is equal to 1 second. If I find, it will be 6 into 1 square minus 12 into 1. You will get it as minus 6 radian per second, guys. Minus means it can either be in anti-clockwise sense, again depending on our sign convention. Usually minus means we will take it in clockwise sense, guys. Right? Sense may either be clockwise or anti-clockwise. How will direction be? In order to find the direction of angular velocity, what we will do? Along the sense of angular velocity, you will curl the fingers of the right hand. Direction of thumb will give us the direction of omega bar or d theta bar, because omega bar will always be in the direction of, or d theta bar will always be in the direction of omega bar, guys. Clear, everyone? Yes or no? Right. We'll see next question. So here answer should be 6 radian per second. A solid cylinder of mass m and radius r rotates about an axis passing through its center, making 60 rpm kinetic energy of rotation. So what is rotational kinetic? I'll do this question in some time. But what is rotational kinetic energy given as? Half I omega square. Solid cylinder. What is moment of inertia? Solid cylinder means same as that of disk, guys. Mr square by 2 into omega square. So I'll get it as mr square omega square divided by 4. Now what is here? Omega value is given as 60 revolution per minute, guys. But omega should always be taken in radian per second. So 60 into, in one revolution, how much angle will be rotated? 2 pi. In each minute, you are going to have how many seconds? 60 seconds. Whole square you can write. So these two will get cancelled out. So you will get 4 pi square. 4 and 4 also will get cancelled out. So I'll get it as m into pi square into r square. This would be your answer. Now what they have given, this question is very important. A rope is wound around a hollow cylinder of mass 5 kg and radius 20 centimeters. If rope is pulled with a force 20 Newton, angular acceleration they're asking. So you consider there is a certain very important case, guys. You consider there is some hollow cylinder. Now what has happened to this hollow cylinder? A certain rope is wound all over it. And what we are doing, we have applied a certain force. The rope is being pulled, guys. So one end, tangentially you are applying a force. How much is it? 20 Newton. They're asking what is the angular acceleration. So now, what will be the situation here? Let us imagine it is present on some surface again, or let us take it is in air only. What are the forces that are going to act? Will weight be acting? Weight will usually act on the ground. Imagine that it is on a surface, guys. Imagine it is on a surface. Weight is usually going to act on a ground. Will ground keep quiet? Certainly not. What is it going to give? It is going to give some normal reaction. Yes or no? Yes, it is going to give some normal reaction. How will that normal reaction act? From this point it will act in which direction? Upward direction. They're asking to find out angular acceleration. Now, in order to find angular acceleration, first I will check whether there is torque or not. So I want to find torque about point O. Please listen very carefully how to find out torque, guys. Right. Now, when we talk about torque, whenever you are interested in finding torque about point O, what I'll do, I will consider an axis passing through point O and perpendicular to the plane. I have three forces, guys. So torque can be due to normal reaction, torque can be due to weight, torque can be due to force. So when I am interested in finding torque about point O, what will I do? I will consider an axis passing through point O and perpendicular to the plane. And what is general formula for torque? It is given as R bar cross F bar. R bar is distance or position vector of the force from the axis. So when we are interested in finding torque about point 2, we took an axis passing through point 2. You see, line of action of weight. Line of action of weight. Is it passing through the axis or not? Yes. Is there any separation between the axis as well as weight? No separation. Because there is no separation, torque due to weight will be 0. In the same manner, I am interested in finding torque about point 2. You see normal reaction. Is normal reaction, line of action of normal reaction, is it also passing through this axis, guys? Yes. Is there any separation? No. So torque due to normal reaction will also be 0. Now, our interest is to calculate torque about point 2. So we consider an axis passing through point 2. You see, there is one more force like this. Is there any separation between the line of action of the applied force and the axis? Yes, there is separation. And how much is that? From the axis till the line of action, it is R. In which direction, beta? Upward. So what I will write? It will be R J cap cross. Where is force acting? I cap. And how you can write torque as? Torque can be written as I into alpha bar. Will be F into R. J cross I, you all know I J K cyclic rule. I cross J is K. J cross I will be minus K, guys. Okay. So what will I get alpha bar as? I will get it as FR divided by I. Okay. In which direction? In sense, see, direction is minus K. Minus K means into the board. When will I get it into the board, beta? I'm going to get into the board if the sense of alpha is clockwise. So along the sense, curl the fingers of the right hand, direction will be inwards, guys. Now please tell me, hollow cylinder is given. Hollow cylinder means same as that of ring, guys. So what will I get this as? Fr divided by moment of inertia will be mr square minus k cap. So what is our alpha bar here? Alpha bar value if you take, you will get it as F divided by m into r minus k cap. If I want to write only magnitude, it will be F divided by m into r. F is given as how much beta? 20 Newton. Mass is 5. Radius is given as 20 centimeters. I can take it as zero point 0.2. So our answer will be fine to zero point 0.2 will be anyhow 1. So alpha value will be 20 radian per second square. Clear everyone? Very important question, guys. Right? Very good question also. So through this question, I have told you how to calculate the torque again. So whenever you want to find torque about any point due to force, right? So torque about any point if you are interested in finding. So what will I do? I'll consider an axis passing through that point and perpendicular to the plane. Now I will see whether the line of action of forces is passing through that point or not. If the line of action of force is passing through that point, there won't be any torque due to that force. If line of action of force is not passing through the point, then there will be torque due to that particular force, guys. Clear everyone? Understood all of you? I hope you have understood. Let us see the next question. Lot of questions. Very important chapter again, the entire system of particles, guys. A solid sphere of mass m rolls without slipping on an inclined plane with an acceleration a. So what is acceleration given as? You know, it is given as g sine theta divided by 1 plus k square by r square. For solid sphere, what is k square by r square? 2 by 5. So what will I get, beta? G sine theta divided by 1 plus 2 by 5 you will get, which turns out to be 7 by 5. I can write 5 by 7 g sine theta will be our acceleration. Acceleration is given. They're asking what is the frictional force acting, guys. Just now I have told you what is frictional force acting. It is given as mg sine theta. In frictional force, you will get 1 plus r square by k square, beta. Yes or no? So what we can write here? Mg sine theta. What will r square by k square value be? You will write it as 5 by 2, which I will get it as 2 by 7 m into g sine theta. Now, how can I write this g sine theta as? Can I write g sine theta as 7a divided by 5 beta? Yes. So what will I get the frictional force acting in terms of acceleration? If I say I'm going to get that as 2ma divided by 5. Clear everyone? Understood all of you? Yes or no? I hope it is clear. Next, if you see a homogeneous cylinder of mass m and radius r is pulled on a horizontal plane by a horizontal force acting on its center of mass. Assume rolling without slipping, means pure rolling. Acceleration of center of mass, they are saying, guys. Again, a direct question. Just now I have told you. Pure rolling on a horizontal surface. So horizontal, usually the surfaces that we take for neat point of view or for mains point of view, we'll consider a fixed surface. Advanced means you will get movable surfaces, guys. Now, how is the force applied? They have given that it is a homogeneous cylinder. Homogeneous cylinder means it will be a solid cylinder, guys. So how is force applied on this solid cylinder? It is applied exactly at its center. So here in this case, because force is applied at the center, what is h value here? Will it be 0 or not? They're asking what is the acceleration? What is acceleration, beta? We got it. F by m into 1 plus h by r divided by 1 plus k square by r square we got. Yes or no? So what I am going to get? F by m. Already in numerator, h value is 0. So I am going to get numerator as 1 plus 0, which is anyhow going to be 1 only. But in denominator, if you see, what is k square by r square value? Solid cylinder is same as that of disk, guys. For a disk, it will be 1 by 2. So here you will get 3 by 2, which I can write it as 2f divided by 3m. This will be the acceleration of the solid cylinder when force is applied at its center of mass, guys. 2f divided by 3m will be the answer for this. Clear everyone? So or no? I hope it is clear. Next case. One more point I would just like to ask guys before moving ahead. So, is the folder not shared with you? Are you not able to view the recordings, guys? Are you able to see the recordings or not? Am I audible? Hello. No. Is recording folder available? Is it visible in that every recording is present till now, till date? Can one of you please unmute and share?
Yes, it is.
Creative Khalam compelling course. All the recordings are available?
Yes, all of them are valid.
Available, no?
Yes, sir.
Right, okay. That is shared as a folder in Drive again. I hope so. Next question, let us see. Two identical disks are moving with same kinetic energy. One rolls and other is sliding only. Okay, the first disk will have which energy, beta? First disk, if I take, it is rolling. So can I say it will have both translation as well as rotational kinetic energy? I can write it as Et into 1 plus k square by r square. But second one is only sliding. So which energy it will have? It will have only translational kinetic energy, guys. So what I can write here? I can write masses are same, I believe. Two identical disks have been given, so you can take same masses, guys. M into V1 square. What is k square by r square for a disk? 1 by 2 again. So I'll get 3 by 4 m into V1 square. Similarly, what is E2 dash here? Half into m into V2 square. They are saying they have same kinetic energy. Here, E1 is mentioned as equal to E2. So I can write 3 by 4 m V1 square will be equal to half m V2 square. M and m will get cancelled out. So what will be V1 square divided by V2 square? I will get it as 2 divided by 3. So the ratio of their speeds of center of mass will be root 2 is to root 3, guys. Second option. Clear, everyone? Now, a circular disk is rotating freely about a vertical axis through its center with angular velocity omega 1. So what do we have initially? We have a certain disk given to us. A disk is rotating, it seems, about a vertical axis. So obviously you can consider the disk is present in horizontal plane. It is rotating about a vertical axis with angular speed, how much beta? Omega 1. A ring having same mass and radius as that of disk. So here initially we have disk beta. A ring having same mass and radius as that of disk is now placed on the disk, guys. So you are taking a ring now and placing on it. Now the system is rotating with a certain new angular speed omega 2. What is the relation they are asking, guys? So here, if you see, in such cases, you can conserve angular momentum of the system. And before the ring is placed, after the ring is placed, there is only rotation. So which angular momentum are we going to have only due to the effect of rotation? Spin angular. So initial spin angular momentum will be equal to final spin angular momentum. Initially, you have only disk, guys. So I can write initial moment of inertia into omega should be equal to final moment of inertia into final omega. Initially, only disk is there. So I'll write this as mr square divided by 2 into omega 1. Finally, you have both the disk as well as ring. So for disk, moment of inertia is anyhow mr square by 2. For ring, what will it be, beta? Mr square into omega 2. So what will I get? Mr square by 2 into omega 1 should be equal to 3 by 2 mr square into omega 2. So what we can cancel out? Mr square can be cancelled out. They're asking us the ratio of omega 2 by omega 1, which you will get it as 1 by 3, guys. 1 is to 3 will be the answer for that. Very important concept based on conservation of angular momentum. Whenever such cases are there, a disk is rotating, two point masses are attached at the ends or on the diametrically opposite points, what will happen to the angular speed? So always remember, as soon as you increase the mass, moment of inertia will be increasing. When moment of inertia increases, in order to ensure that angular momentum remains constant, angular speed will decrease. I omega has to remain constant if only rotation is there, guys. Clear, everyone? Yes or no?
Yes, sir.
Let us see one more question. Cylinder of mass 10 kg and radius 15 centimeter is rolling without slipping on a plane of inclination 30 degrees. Coefficient of static friction is given. If the inclination is increased, at what value of theta does the cylinder begin to skid and not roll perfectly? So we know the maximum angle of inclination for which object performs pure rolling. I have written the formulas. You need to be thorough enough with the formulas. It is given as tan inverse into mu into 1 plus r square by k square. Yes or no? This is the maximum angle for which you take any object and place it on a rough inclined plane, it will execute pure rolling. Above this angle, it will not be executing pure rolling, guys. So here in this situation, what will I get now? Tan inverse of mu value is given as 0.25. You can take it as 1 by 4. What is r square by k square for a cylinder? Again, consider it to be solid cylinder because nothing has been mentioned. Solid cylinder same as that of disk, guys. K square by r square is 1 by 2. R square by k square will be 2, guys. So what I'll get this as tan inverse of 3 by 4. So what is, for which angle will tan be 3 by 4? 37, guys. So what they're asking, at what angle? Till here, pure rolling. After this, pure rolling may not take place, guys. So 37 degrees will be the angle till which pure rolling will take place, or just above which cylinder will start to skid and not roll perfectly. Means slipping will take place, guys. Clear, everyone? Yes or no? Let's see the next question, guys. System to be in equilibrium, the torques acting on it must balance. This is true only if the torque taken any point, guys. Now, whenever we talk about equilibrium, as I've said before also, when I say equilibrium, right, till work energy power, we will focus only on which equilibrium beta? Translation equilibrium. There are two types of equilibrium in general. What are those? First one will be translational equilibrium. The other one will be rotational equilibrium, guys. Now, what is the meaning of translation equilibrium? Whenever there may be external forces, but the resultant of the external forces, net external force acting on the system, if it is zero, then I will say the system is said to be in translation equilibrium. And when will it be in rotational equilibrium? Net torque acting on the system. There may be forces, there may be torques, but overall, if you add up all the torques, net torque should be zero. And when I say net torque is zero, the torque can be about any point, guys. It can be about any point. It may be within the system, outside the system. So when I say system is in equilibrium, the torques acting on it must balance. This is true only if the torques are taken any point, guys, whether you take on the system, inside the system or outside the system. Understood, all of you? So or no? This is one very important question. We will do this. This would be the last question for the day. Tomorrow, whatever questions are there, we will try to complete all those questions. And tomorrow you can also write. Yesterday, motion straight line, motion in plane, laws of motion test. The validity of the test has been increased, right? It has been extended till morning 8 o'clock, guys, tomorrow. Similarly, after the class tomorrow, the test 5 which is uh, based on work energy power system of particles. Tomorrow that will be activated, right? Right after the class. So you can do that test till Sunday morning. Somewhere 1 hour you can utilize and you can solve it. Then on Sunday we will do gravitation and system and units and measurement, right? That also test will be conducted on Sunday itself, guys. So it's just about 1 hour of practice daily, guys. As simple as that. You are listening for 2 hours, 1 hour you practice, right? Certainly it will be helping out in the final exam. And we are very near, right? Till Friday, right? Din raat ek kar do bhai, huh? You have to put lot of work till maybe Thursday or Friday afternoon or Friday evening. Till that you study properly. Saturday you can relax and study. I'm not saying you should not study. Relax and study. Sunday you leave, guys. If those who feel that yes, even if I study, it will not be a big deal, you can continue studying till exam also, huh? Till you appear for exam. But that would not be I would not suggest you doing it, guys. We'll do one more question. Figure shows a uniform rod of length L moving such that velocity of center of mass is omega L by 6. If the end A of the rod is suddenly see, देखो, very simple logic. Now this is moving, guys. It is moving, means it has translation. What I'm doing, I'm suddenly fixing it. Will it rotate or not? Initially, you see, it is coming like this. It is translating. As soon as I fix this end will not be moving. So it will be rotating. So here what will happen? Translation is getting converted into rotation. So due to translation, what are we going to have? It's a very important question, guys. Due to translation, we are going to have which angular momentum? We are going to have orbital angular momentum. Now this end became fixed. So just before this end is fixed, guys, what is happening? There is some velocity to the rod. Just after, what will happen? It will rotate with some angular velocity. What is the angular velocity they are asking? So what is happening here? Translation is getting converted into rotation. So I can say whatever orbital angular momentum is there before fixing or before suddenly fixing it, that will get converted into spin angular momentum after fixing it, guys. What is orbital angular momentum given as? R bar cross P bar. What is spin angular momentum? I into omega bar. Now, here angular momentum should be conserved about point A beta. So whenever you are trying to conserve angular momentum about point A, or whenever you are trying to calculate angular momentum about point A, firstly, we will consider an axis, just like for calculation of torque we did. In the same manner, we are going to do here, guys. Right? Firstly, we are going to consider an axis passing through point A. There we took line of action of force for calculation of torque. Here we are going to take line of action of linear momentum. And as we all know, linear momentum is given as mass times of velocity. In whichever direction velocity is there, in that direction we are going to have linear momentum. So we want to find angular momentum about A. So I'm going to consider an axis passing through point A. This is the line of action of linear momentum. Is there any separation? Yes, it is there. What is the separation, guys? From the axis to the line of action of linear momentum. It is L by 2. In which direction, beta? L by 2 in downward direction. Cross M into V I cap. What is moment of inertia? About an axis passing through one of the end and perpendicular to the length for a rod? ml square by 3 into omega bar. So what we can write here? M into V into L divided by 2. J cross I will be minus K. Minus of J cross I will be K cap. Should be equal to ml square divided by 3 omega bar. From this, M and M will get cancelled out. L and square will get cancelled out. What will you get omega bar as? You will get it as 3V divided by 2L K cap. K cap means direction is outward. When will direction be outward? When the sense is anti-clockwise, guys. So I can write omega bar as 3 divided by 2L. V value is already given as omega L by 6. So I'll get the answer as omega by 4, guys. Clear all of you? It will be omega by 4 K cap. K cap means sense should be anti-clockwise. Okay. The rest of the questions we will try completing tomorrow. Right? Vaishnav, you didn't remind me to discuss the questions again, to share the answers in the morning, so I forgot. So please do remind me so that at least tomorrow I can share those answers. Anyone who has any doubts, please send them, guys. Hopefully I'll try to share the solutions by tomorrow afternoon, probably tomorrow evening, right? Or else we can discuss those questions in the class after completion of the questions of system of particles. So tomorrow we will wind up system of particles, and we'll start. We'll not start, but tomorrow you will also write work energy per unit system of particles. It's a very simple logic, guys. 2 hours you listen. While you listen, only almost 60% you can absorb, guys. If you listen with effective concentration, 60% of what you are listening will be absorbed, and you can, during the exam, you can produce 50% out of whatever you have studied again, right? So almost 90% you can do it. So already 60% you're absorbing. In whatever you're absorbing, 90% you can produce on the day of the exam. So please listen effectively. Again, we don't know whatever questions we are discussing. Maybe some questions, maybe 20 questions of some type of same type are repeating. 20 questions, if you have listened thoroughly, 20 questions you can do, 80 marks will be in your hands, guys. Right? So I am focusing majorly on doing easy and moderate questions only, so that easy and moderate level paper you can solve effectively. Okay, so on that note, we'll be meeting tomorrow, right? So from that's it from my end for today, right? Take care, everyone. Thank you all. Bye bye, all of you.
Thank you, sir.
Thank you, guys. Take care.